So, can I move to the next presentation? Thank you. Thank you, Dr. Indu.
Yeah, okay, thank you very much. Then I will start my presentation. Okay, can you see my my slide?
Yeah.
Okay,
So,
so
I'd like to introduce Dr. Haichuan Yang from Tokushima University, Japan. And his title is An Improved Spherical Evolution with Enhanced Exploration Capabilities to Address Wind Farm Layout Optimization Problem. Doctor, please go ahead.
okay, thank you very much. My name is Haichuan, and I'm from Tokushima University. And today I want to introduce my research about improved spherical evolution with enhanced exploitation capabilities to address wind farm layout optimization problems. So, firstly, I will introduce the research background. And the picture in the left is take in the Japan famous Japan city in Yokohama. So optimization problems involve finding the best solution from various options. The goal is to either maximize or minimize the target function while meeting certain constraints. And in here, here is the figure. In the figure, we can find that if we want to get the maximum value of the current, then we should set the temperature at 55. So this is the optimization process, and this figure A is also a one-dimensional solution space. And if we consider the temperature and pH in the same time, then the solution space will become a two-dimensional solution space in the right side. So there are many optimization problems with 100 or even 1,000 parameters that influence the fitness value. So at that time, the solution space will become 100, even 1,000 dimensional solution space. So at that time, the problem will become very complex. So finding an exact solution for these complex issues often requires extremely large computational time, making it impractical to solve within a reasonable time frame. Some classic example of problems hard to precisely solve include traveling salesman problem, knapsack problem, and so on. So all the aforementioned problems are classified as NP hard. So meta-heuristic algorithms have emerged as effective strategies for addressing the complex optimization problems. Genetic algorithms are inspired by the process of natural selection and genetics. So here are some interesting applications of the meta-heuristic algorithms. The unique nodes of Shinkansen N700 series models in Japan is the result calculated by genetic algorithm. And recently, researchers at the University of Vermont have developed a biological robot called Xenobot using an evolutionary algorithm. And then I will introduce the research motivation. So in recent years, electricity prices in Japan have risen about 30% on average from 2021 to 2022. So to lower energy prices, the Japanese government is proposing various policies to promote renewable energy. However, the high costs affect the public burden. Compared to Western countries, solar panels and wind turbines traded internationally are about 1.5 times more expensive in Japan. So in wind farm design, if turbines are too close, turbulence will reduce the performance of nearby turbines. Therefore, optimizing turbine placement can minimize turbulence effects and improve overall efficiency. So, in fact, turbulence has been known from a long time, from Leonardo da Vinci's manuscripts to Van Gogh's Starry Night, from China's painting to Japanese painting. Painters have used their artistic brush to coincidentally depict visual image of turbulence. Turbulence is an extremely complex phenomena of physics. In 1922, Heisenberg published a calculation entitled this in the Annals of Physics. This problem is a classical problem of turbulence. Determine the exact transition from laminar to turbulent flow, and one so difficult that Heisenberg provided only an approximate solution. So I believe AI can help address these complex issues. So I am researching AI-based optimization of renewable energy systems to reduce costs in Japan. This research is funded by GST. So then I will introduce the research method. So here is the top view of a wind farm. The figure A shows a poor layout, while figure B shows a good layout. And actually, the figure and the B is very simple, so we can easily get the best layout like the figure B in the right side. But in the real world optimization problem, in the large-scale wind farm, the problem will become a very complex situation, especially the wind direction is from everywhere. So such optimization being an NP hard problem requires advanced calculations considering turbulence between turbines. Since the MHAs are able to provide a feasible solution to the problem at an acceptable cost, they become an important tool for solving wind farm layout optimization problems. So what I'm doing is try to use explainable artificial intelligence to solve this problem. Various MHAs are used for optimization. The challenge is selecting and customizing the right algorithm for WFLP. And many methods rely on trial and error, running many algorithms to find the best one, which consumes significant computational resources. So I try to use complex network to deal with this problem. MHAs exchange information between multiple individuals during the iterative process of the algorithm. This interaction can be represented as a complex network. By analyzing the algorithm using the complex network, we select and developed an MHA with a network structure suitable for solving the WFLP. So then I will specifically introduce the optimization process. Firstly, generate several layout solutions. Each solution is also an individual, like the X1, X2, and Xn. And next, there is a multi-agent operation that randomly changes the position of the specific wind turbine. So the number from 6 changes to 5. So the new wind farm layout will be designed. And next, there is a crossover operation that randomly combines partial layouts of two schemes. Finally, a new scheme X1 star and X2 star are generated. And in here, the information between the X1 and X2 is exchanged. And then is the evaluation. So the all of the layout will be input into the model and get the energy output. And then we will selection. Compare the power output of the sub-scheme with that of the parent scheme. Retain the better scheme and eliminate the inferior one. And this is the iterative process of the genetic algorithm. Interestingly, evolutionary algorithms can be classified into two types based on complex networks. During the iterations of the algorithm, we can count the number of communications between individuals and fitted the obtained data. So as I said before, in here, there is some information communication between the schemes. Also can be said there are some information exchange between the individuals. So as the algorithm running, the information change will form a very large, very complex network. So eventually, it was found that some algorithms form small world networks with Poisson distribution, while some others form networks with power law distribution. And during the course of the research, we discovered a correlation between the algorithm and the problem being optimized. There are generally two types of problems being optimized: multimodal problems and unimodal problems. And the evolutionary algorithms, which is also the meta-heuristic algorithm, with small world network characteristics are suitable for optimizing multimodal problems, while algorithms with power law distribution network characteristics are suitable for optimizing unimodal problems. And then I will introduce the result. And here the picture is Toyama in Japan. It's a very beautiful mountain. So example results show that SE and DE algorithms with small world network properties are superior to CJDE and SCJDE with scale-free network properties on WFLP. So we speculate that the WFLP is more oriented to multimodal problems and therefore propose improved SE. And experimental results show that the ISE is superior to SE, DE, CJD, and SCJD on WFLP. And also the proposed ISE is confirmed to be clearly superior to the SUGG algorithm proposed by MIT in terms of energy output in WFLP. And here is the paper which has been published in the engineering applications of artificial intelligence. And finally is aspirations. So looking ahead, I will leverage the leading position of Tokushima University in the sustainable development growth to continuously expand in interdisciplinary research in artificial intelligence and renewable energy. I aim to contribute to sustainable development in the world. So here is all of my public presentation. So maybe it's a little bit short, but thank you very much for your listening. Thank you.
So, any questions for him? If you have any questions, please post an email to him. I'm sharing his email address. You can email for any doubts, questions, and thank you, Mr. Yang.
Thank you very much. If you have any problem, you can connect me with the email. Thank you very much.
Yeah, sure. Thank you.